finally, for this session, I'm really pleased to welcome another member of our Medical Advisory Board, Professor Paulo Stanga from the Institute of Ophthalmology at University College London. Paulo is going to talk about retinal implants and how they might restore some vision.
Thank you very much, Kate. It's a pleasure to be here. Thank you very much to Retina UK for this invitation. It's a privilege to speak to you, accompanying all these very exciting speakers. Let me share with you our experience in artificial vision. I run a retina service at the Retina Clinic London here in London on Harley Street. We're an independent clinic. We run several clinical trials. We participate from several international clinical trials in gene therapy, in dry AMD, and other trials in wet AMD, diabetic macular edema, amongst others. So I'm going to talk to you on artificial vision. I'm going to try to keep my message clear and short, because I realize that it is my presentation that separates you from the break and a nice cup of tea. So what is artificial vision? Well, artificial vision is creating vision, eliciting the perception of vision by passing the photoreceptors, which is the normal pathway. We can do this working within the eye, or we can do this also stimulating the cortex when directly working on the brain. So we have to remember that the visual pathway starts in the eye, the retina, and then it extends to the cortex at the back of the brain. So this is the first patient to have a cortical prosthesis at the Dobell Institute in Switzerland. You can see that this patient who passed away because of unrelated reasons is wearing a pair of glasses with a camera, and there's a cable going directly through the skull into the brain and transferring information directly into the cortex. So the patient was able to perceive phosphorescent light, and whether the light was on or off. Mark Humayon in the US, in California, did the first studies stimulating directly the macula with electrodes. And this is the Argus 2 retinal prosthesis, the one I have been using in both retinitis pigmentosa and age-related macular degeneration. So basically, this is not that it is not that we are replacing the eyeball. It is not a bionic eye, as the press calls it, and it is not, as we remember Steve Austin from the $6 Million Man, where the whole eye got replaced. Unfortunately, we're not there yet. So it is a chip. Here you can see a chip of 60 electrodes that we implant, and we tack with that device that looks like a nail directly onto the macula, over the retina. And initially we started using it in patients with retinitis pigmentosa, very advanced retinitis pigmentosa, with vision of only perception of light. And here are the results. So it worked really well. 97% of patients managed to identify a square on a monitor. 57% of patients managed to detect direction of motion. In 23%, we managed to measure vision using a grate. And in 10% of patients managed to identify letters the size of a pack of cigarettes. So it's always the question, well, what can patients achieve? How good is the device? Well, we looked at object localization, motion discrimination, visual acuity, letter reading, orientation, and mobility, of course. So in 2010, we were the first ones to describe the ability of patients to identify letters. This was thought impossible, and this is the first patient that managed to identify letters on a screen. It took time because the patient had to identify the vertical part, the horizontal part of a letter H, for example, but it was possible. We have to remember this, our patients, all the patients that we implanted at the time had vision of only perception of light. And then we looked at all the different parameters that I've just discussed. This is one of the patients I operated, and as some of you may be able to see, the patient is following a path, is holding a white cane, but is not using the white cane to identify the edge of the path. The patient could identify the edge of the path. These patients managed to perceive the difference between light and darkness and patterns created by phosphenes. So we looked at, we also looked at everyday life tasks. And if you can make this video work, please. So here we can see how patients found it easier to identify whether they had a plate, for example, on the table. And this is Keith. He used to be a butcher in Hull, and he had a, once I asked him, well, what was the best thing that you managed to achieve with the Argus 2? And he said, well, it's very easy now for me to find my pint of beer in the pub. So this is Steve. Steve used to be a theater technician. He was the first person in the world to identify letters on a screen, and this is the work we presented in 2010. So I'm not going to bore you with all of these, the different percentages of letters. We did a functional low vision observer rated assessment to see how the device assisted patients in real life. We also looked at whether patients could perceive color. And this is the research that we've done. We presented at the ARVO research meeting, which is the largest research meeting in the world. This is some years ago. And we showed that patients could perceive two colors at the same time. But we have to remember that all of this was believed to be impossible before we did all this work. And then we also looked at face recognition with the benefit at the time of algorithms similar to those that you now find on an iPhone or a Samsung phone. I have no commercial association, unfortunately, with iPhone. So we also looked at whether artificial vision was of any benefit in geographic atrophy, advanced geographic atrophy in AMD. Again, this was believed to be impossible. Everybody said, why do you want to do this? Patients have peripheral vision, and the central area of the macula is dead. You're not going to see anything. There's atrophy. Okay, so we registered it as a study. We had to obtain ethics approval, MHRA approval, because it was a new indication for the Argus 2, and we looked for patients with geographic atrophy, advanced large areas of geographic atrophy, vision below 660. And I did the first implantation in 2015. I was in Manchester at the time. I've moved to London 5 years ago and brought all my research with me. And these are some examples. I don't want to bore you with the surgery, but these are some stills of the surgery as I'm doing it, as I'm tucking the chip directly over the macula, over the area of atrophy. And as you can see here in this photograph, the device consists of a chip that goes implanted and tucked directly over the macula. There is a flat cable that comes out of the eye, and there is a device. All the electronics are within a pack that is sutured to the wall of the eye on the outside, and it's about the size of a pound coin. So it's a bulky thing, but it did work, especially in patients with retinitis pigmentosa. So we did show, those are 3D. We specialize in imaging, so those are some of the 3D renderings that we've done. So, and that's the implant directly over the area of atrophy, which you see under the implant in black. That's at 6 months. So it did work. We showed for the first time that it was possible to elicit a visual function in AMD using artificial vision. Other companies followed what we started. This is a patient drawing the face of his brother. He looks a bit better than that in real life. So what is happening in artificial vision at the moment? Well, sadly, Second Sight, which is the company that was manufacturing the Argus 2, as all of the other companies have stopped making implants for retinitis pigmentosa. It used to cost, for you to have an idea of cost, the list price in the UK was £62,000 just for the implant. When you had to add the cost of the surgery plus the cost of rehabilitation, it amounted to almost £100,000. It's a huge amount of money. It was even more 5 years ago. When you take into account that most of the patients that were suitable for this technology could not work most of their productive life. So, because, they suffer from an IRD that started in early life. So, but research continues. There are several groups that continue doing research. There's a company called, so there are groups in Australia, there are groups in China, groups in different parts of the world that continue doing research in artificial vision. Second Sight, the company that was manufacturing the Argus 2, is working on the Orion project. The Orion project is implanting the same chip as I was using in the retina, implanting it directly in the cortical occipital region of the brain, at the back of the brain, to stimulate the brain directly, with the aim of bypassing completely the eye. This way, it would be suitable for patients that had suffered from ocular trauma, enucleations, or with complete optic nerve atrophy. There is now a company called Pixium that's looking at subretinal implants with photovoltaic cells. So these are light-powered cells, and they are following our footsteps, and they are now they are doing a trial in geographic atrophy. So far, neither us nor anybody else has found a cost-effective way of using artificial vision. Thank you very much. I would like to thank my team, and it's been a pleasure to be here, and thank you to Retina UK for this invitation.
Thank you very much, and thank you, Professor Stanga, and to Mr. Jouet. I think we're much more on track than we were, so thank you for that. We've got a break now before we return for our Q&A session, which I believe is at 2:55. Yeah, so do go and have a cup of tea or coffee, and we'll see you back here. Yeah, so questions, if you don't want to raise your hand and ask your question directly, there are some cards available. You can write your question on a card and put it in the box, which is on the Retina UK stand. So you can do that if you want to.